Hi all. These are your sex-linked genetics problems, problem set number 3. So we'll do a couple of sample problems and then we'll cut you loose and let me know if you have any questions. So the first question is very straightforward. I want to be sure that you're comfortable with what the possibilities are and the probabilities are for a male and female child. So let's dissect the problem. It says male Homo sapiens have the genotype XY for their 23rd chromosome, and female Homo sapiens are XX. This is what we talked about earlier in your Cornell notes. Draw a Punnett square and explain the expected genotypic and phenotypic ratios of a cross between a male and female Homo sapien. So, what are we dealing with here? We have a male and a female. He is XY, she is XX. Trying to set the stage here for your genetics problems. There's no there's no hemophilia, there's no color blindness, there's no DMD or SCID or any other sex-linked condition here. I just want you to focus on the sex chromosomes. So, look at the Punnett square. She carries 2 X's. She separates those 2 X's and offers her child one of her 2 X's. The male then either offers his offspring the X or the Y. Fertilization of sperm and ovum gives you XX. Fertilization, XX. Fertilization again across the bottom, XY. And a last time for XY. So when you look at the genotypic ratio here, there's only 2 possible genotypes. It's either XX or XY. 2 of the offspring could be XX, 2 of the offspring could be XY. So this is the opposite of the problems that we did earlier where we had 4 and 5 and 6 different genotypes. Here, there's only 2. But notice the sum of the probabilities is still 4. It's always 4 from the Punnett square. And then your phenotypic ratio, the offspring is either female or male. Possibilities are 2 and 2. So the probability of a male or female child every time is 50-50. And you'll hear people say, oh, they've had 2 daughters, so it's time for a son. They've had 3 sons, so the next one's probably going to be a girl. That is not accurate. The probability of a child is 50-50. There is no change in the probability based on the previous children, even though people talk about this all the time. All right, so that's question 1. That sets the stage for the sex-linked traits. Then I'm going to jump forward to question number 5, where you're playing the role of a genetic counselor. This is a cool question. Do a little role play here. So it says, if you are a genetic counselor and a hemophiliac female, so she's a hemophiliac, she walks into your office. She states that she wants to reproduce with a healthy male, but she has concerns about the health of their offspring, as any parent would. With your knowledge of genetics, what would you be able to tell her? So what I want you to think about here is if you have a female walking into your office, right? She's a female, so she's XX, and they tell you that she's suffering from hemophilia. So you'll see from the earlier problems that hemophilia is a recessive sex-linked disorder, which means the lowercase h, the recessive allele, is your hemophiliac condition. That means your capital H, your dominant H, is typical, or your healthy condition. So if she is a hemophiliac, that means that she carries and expresses both copies, 2 copies, of the detrimental recessive allele. So that means as a female, she's this. And that's really serious because as a male, I received my X from my biological mother. Well, if my biological mother only offers the detrimental allele, That means the only thing she has to offer her sons is the detrimental hemophiliac allele. And that's what I want you to discuss on number 5. So this isn't a question about ratios. This is a question about make the cross between the hemophiliac female and the healthy male. So here's your hemophiliac female and your healthy male. Let me fill in the alleles. Hemophiliac female, healthy male. I want you to fill in this Punnett square and then talk about what the probabilities are for their children and play the role of the genetic counselor and give her feedback. All of the other problems should be based on the Cornell notes that we worked on earlier and the sample problem that I provided earlier. And anything that doesn't make sense, drop me a line. Send me a text, email, Jupiter, Messenger, and I'll be happy to help you. Talk to you soon, everyone.